Assalamu alaikum. Welcome to the second part of today's lecture, which will continue discussing the network layer. In this part, we will discuss the Internet routing protocol. In this part, we're going to discuss the Internet protocol addressing, the Internet control protocols, inter-domain routing systems, and intra-domain routing systems. The Internet protocol is a network layer communication protocol in the TCP/IP protocol suite. Its main function is relying datagram across the network boundaries. Its routing function enables internet working, thus the internet. IP task is delivering packets from source to destination based on IP addresses. For this purpose, IP defines packet structure and encapsulates the data delivered to network layer, and it defines addressing methods that are used for the datagram to reach from source to destination. Internet version 4 datagram consists of a header and a body or a payload. The header has 20 bytes fixed part and a variable length optional part. IP header fields are version to keep track of which version of the protocol the datagram belongs to. Currently, there are two versions, version 4 and version 6. The IHL, it will tell how long the header is. The IHL least value is 5 and maximum value is 15. Differentiated services, 3 for priority, 3-bit signals whether the host cared most for delay, throughput, or reliability, and 2 are unused. The differentiated services currently are used, 6 are used for the service class and 2 for congestion. The total length is the length of the header and the data, the payload. The maximum length is 65,535 bytes. Identification is the ID of the datagram. DF is a down-fragment bit for packets less than 576 bytes. MF, that means more fragments. If the packet is fragmented, it will tell how many fragments left. Fragment offset will tell where the current datagram this fragment belongs to. And time to live is a counter used to limit the packet lifetime. Protocol, it will tell which transport layer protocol has given the data to the datagram, and the list of the protocols is listed in the link below. Header checksum will verify the header only. Source and destination addresses indicate network numbers and host numbers for source and destination. Options, here are some options. Security will specify how secure the datagram is. The strict source routing gives a complete path to be followed from source to destination. Loose source routing gives a set of routers that cannot be missed. And record route, this for each router on the route to append its IP address. Timestamp is appending the IP address along with the timestamp. IP addresses consist of 32 bits, that's 4 bytes. It's represented in a decimal format separated by dots. There are 5 classes of IP addresses. The first is A with 1 byte for the network portion and 3 bytes for the host portion. The B class with 2 bytes for the network, 2 bytes for the host. C class with 3 bytes for the network, 1 byte for the host. That means A has the smallest number of networks with the most number of hosts per network, and C has the largest number of networks with the smallest number of hosts per network. D is for multicasting. E is reserved for future uses. There are special IP addresses. All zeros mean this host. All zeros in the network section and host ID. That means host on this network. All ones mean broadcast to the local network. Network with all ones, that mean broadcast to the destination network. 127 dot anything is local host. That means this host is sending this packet to itself. Having 32 bits address limits the number of available IP addresses. Therefore, we need better utilization for the available network IP addresses. A possible way of doing this is to allow a block of addresses to be split into several parts for internal use as multiple networks while still acting like a single network to the outside world. This is called subnetting, and networks such as an Ethernet LAN that results from dividing up a larger network are called subnets. To determine subnets, detach each interface from its host or router, creating isolated islands of networks. Each isolated network is called a subnet. Subnet part is the highest order bits of the IP address. Host part is the lower order bits. A subnet is device interfaces with the same subnet part of IP addresses can physically be reached to each other without intervening a router. As we can see here, we have 3 different subnets connected by 3 routers. Each subnet seems to be one IP address to the router, while inside the subnet there are multiple hosts. Another issue with IP addressing is router table explosion. That means router tables have many entries to the extent that it explodes. Despite that, the blocks of addresses are allocated to multiple subnets to reduce the number of IP addresses used, but still the problem remains. To reduce routing table size, we can apply the same concept of subnetting for routers in different locations can know about given IP address as belonging to a prefix of different sizes. Instead of splitting the address block into subnets, we combine multiple small prefixes into a single larger prefix. This is called aggregation. And the result is larger prefix called supernet in contrast with the subnet, which depends on division of blocks of addresses. The protocol used to maintain this is classless interdomain routing, or CIDR. The subnet portion of the address of arbitrary length addresses format a.b.c.d/x, where x is number of bits in subnet portion of the address. An example here is the first address in Cambridge University addresses is 194.24.0.0, and the last address is 194.24.7.255. How there are 2,048 hosts, and the prefix is 194.24.0.0/21. For Edinburgh, the prefix is, it has 1,024 hosts, and the prefix is 194.24.8.0.22. For Oxford, they have 4,096 hosts. The prefix is 194.24.8.0.22. 192.24.16.0/20. So how a host get its IP address? We have two options. It could be hard-coded by the system administration in a file in Windows. That's control panel / network / configuration / TCP IP / properties. In Unix, it's etc/rc.conf. Or it can be obtained by using dynamic host configuration protocol. That's to say, dynamically get the address from a server. It's just plug and play. How the network gets subnets from part of the address? The answer is it gets allocated from its ISP, service provider, internet service provider. The internet service provider has a block, and it dedicates portions of this block to different organizations. The hierarchical addressing of internet protocol actually used to have efficient advertisement of route information. For example, we have two ISPs here. Each one has a range of IP addresses. It uses a prefix for the rest of the internet to reach it. Sometimes it needs more specific route, so it uses a specific IP address. Network address translation is a technology used to connect networks to the internet. While the local area networks can use just one IP address as far as the outside world concerned, there is no need to allocate a range of addresses from the ISP, just one IP address used for all devices. That means the internal IP addresses can be changed without notifying the outside world, and the ISP can change without changing the internal IP addresses. Devices inside the networks are not explicitly addressable. They are visible by the outside world as a single IP address, and this is a security plus. The implementation of network address translation is the outgoing datagram replaced by source IP address port number for every outgoing datagram with NAT IP address and new port number. For the remote client servers, they respond to the NAT IP address with a new port number as destination address. The NATing has to have a table to translate the source IP address and the port number to the network IP address and the host and the new port number, and to reverse the operation upon receiving packets. As we can see here, all the datagrams leaving the network have the single source IP address and different port numbers. The datagrams with the source destination, with the source or destination in this network will have the same internal IP addresses. The NAT table, as we have said, consists of WAN side addresses and LAN side addresses. In the LAN side, at first, a host will send a packet with its internal IP address number and the global destination IP address number. In the NAT table, the local IP address will be replaced with a global IP address, and the port number will be replaced with another port number. These entries are kept in the NAT table. the packet will be sent with the new port number and the global IP address number. Upon receiving a packet, the NAT software will go and check its table and will replace the global IP address number with the local IP address number and the local IP port number. So the packet will reach the source. With the 16-bit port number field, it's possible to have up to 60,000 simultaneous connections with a single LAN address. But still, NAT is controversial because routers should only process up to layer 3, while in NATing they process up to layer 4. And NATing is possibly taken into account in for app designers, for example, people-to-people applications, and the address shortage should instead be solved by IP version 6 instead of NATing. Internet Control Message Protocol is the protocol used when something unexpected occurs during packet processing at the router. Internet Control Message Protocol, also used to test internet. It has about a dozen of messages. The principal Internet Control Message Protocol types is destination is unreachable, destination unreachable when a packet cannot be delivered, either because the destination address is not correct or the destination is down, or the packet is too large to pass through routers with don't fragment bit set to 20. Time exceeded, it's when the time to live field hits 0. This message is sent to the source telling them that the packet is discarded. Parameters problem when invalid packet header field occurs. Source quench is sent to the source when there is a traffic jam or a congestion on the way. Redirect to teach the router about the geographic of the network and to find a better path. Echo request was to ask a machine if it's alive. Echo response or echo reply is yes, I am alive. Timestamp request is the same as echo request, but with timestamp, and timestamp reply the same as echo reply but with timestamp. Address resolution protocol is a protocol used by hosts to obtain the data link layer addresses of other hosts on the local area network. For example, host 4 with the IP address 192.31.63.8 with Ethernet address E6. If host 3 wants to send to host 4 and it knows its IP address, it needs actually its physical address to communicate with it directly. And here it used ARP, sending a flooding message to all hosts on the network asking whose IP address it is. The concerned host will reply with the message saying that this is my IP address and this is my data link layer address. Dynamic host configuration protocol, as we have mentioned earlier, is used by hosts to obtain their IP addresses dynamically, where there is a DHCP relay in the network that connects the network with the server on the other network to obtain IP addresses. After we discussed the routed protocols, that means the protocols that are sent over the subnet, it's time to discuss the routing protocols, that's to say the protocols that are used to determine the route. The first one to discuss is RIP, Routing Information Protocol. It's a distant vector protocol. It was included first in Linux BSD in 1982. A distant metric is number of hops with maximum matrix 15 hops. Anything above 15 is considered infinity. RIP advertisements are sent every 30 seconds via response messages, also called advertisement. Each advertisement have a list up to 25 destinations within the AS. The RIP routing table looks as in the example. Here, RIP routing table for router D. W is reached through A in 2 hops, Y is reached through B in 2 hops, Z is reached through B in 7 hops, and so forth. It has the same problem that distant vector algorithms had, which is count to infinity. Here it's limited by the maximum number of hops, that is 15. So they won't be count to infinity. Anything more than 15 will be considered infinity. If no advertisement is here from the neighbor within 180 seconds, then the neighbor link will be declared dead, and the routes via the neighbor will be invalidated. New advertisement will send to the neighbor telling them that this neighbor is down, and in turn the neighbors send these advertisements if their table has changed. A link failure into information is quickly propagated to the entire network, and Poisson reverse is used to prevent ping-pong loops in finite distance. Infinity equals 16. RIP routing table is managed by an application level process called root daemon, and the advertisements are sent to UDP packages, periodically repeated every 30 seconds, as we have said. The other routing protocol we're going to discuss is Open Shortest Path First. Open is publicly available, and it's used link state algorithm with the shortest path first, mean that it's used Dijkstra's shortest path first algorithm. The open shortest path first advertisements carry one entry per neighbor router. Advertisements are propagated to the entire autonomous system via flooding, and OSPF messages are carried directly over IP rather than TCP or UDP like RIP messages. OSPF has hierarchy. It has 2 levels, the area level and the backbone level, where the backbone level is called area 0. Each area has internal routers and a border router that is connected to the backbone routers. As we have said, OSPF has 2-level hierarchy, local areas and backbone, link state advertisement only in area. Each node has detailed area topology, but doesn't know anything about other areas, except for the shortest path for the other networks in other areas. The area border router summarizes the distances to the networks in its own area and advertise to other area border routers. The backbone routers runs OSPF routing limited to the backbone only. The boundary routers connect every other autonomous system. Both RIP and OSPF are intra-domain routing protocols. That's to say, they're used to route data inside an autonomous system. For routing between autonomous systems, BGP is used, Border Gateway Protocol. It's the de facto standard, and it uses policies to determine routes in opposite of metrics used by intra-domain routing protocols. BGP provides each autonomous system with the means to obtain network subnet reachability information from the neighbor ASs, propagate the reachability information to all internal routers in the AS, determine the good routes subnets based on the information and policy. It allows a subnet to advertise its existence to the internet saying, I'm here. Any pair of BGP routers اللي هم BGP peers exchange routing information over semi-permanent TCP connection, and it's called BGP sessions. BGP sessions are not correspond to physical links. It can run across multiple ASs. When AS2 advertises a prefix to AS1, AS2 is promising it will forward the datagram destined to this prefix towards the prefix. You can see here the dashed links are external BGP sessions, and the dotted links are internal BGP sessions. With external BGP sessions between 3A and 1C, area 3 sends prefixes reachability information to area 1. 1C can use internal BGP to distribute this new prefix reach to information to all routers in the AS1. B1 can re-advertise this reach into area 2 over B1 to A2 external BGP session. When routers learn about the new prefix, it creates an entry for the prefix in its forwarding table. When advertising a prefix, advertisement include BGP attributes. That's to say a prefix, those attributes equals root. There are two important attributes, an AS path and next hop. AS path contains AS through which the advertisement of the prefix pass. For example, AS7, AS6, AS67, AS17, AS3, and next hop indicates a specific internal AS router to the next hop to the AS. Maybe multiple links from the current AS to the next hop. When gateway router receives an advertisement, it used the import policy to accept or decline the router's policy. BGP select route after learning about more than one route with the same prefix. The router must select one route. The elimination rules are local preferences like value attributes, policy decisions are using the shortest AS path or the closest next hop router, which is known as hot potato routing, or maybe additional criteria. BGP messages exchanged using TCP. The messages are open, that opens a TCP connection between peer routers, update, advertise new path or path withdrawal for an old path, keep alive, keeps connection alive in the absence of updates, also acknowledge and open requests, notification, reports an error to the previous message used to close and also used to close connection.